few basic prompt engineering techniques. Let's look at a couple of advanced prompt engineering techniques today. So the first one of them is analogical prompting. So the new prompt engineering approach by DeepMind company aims to revolutionize large language model reasoning. Humans often solve problems by recalling related problems and applying past solutions, right? So DeepMind's approach prompts the LLMs to mimic this human reasoning process for effective problem solving. So usually, whenever we face a situation in life, right, as human beings, we automatically, our mind starts thinking about the past experiences, okay, based on our knowledge, our past experience, we will draw inferences and try to understand what could be the consequences of this action and behave accordingly, take a decision accordingly, right? So this sort of applying what happened in the past to the present and solving a problem is nothing but analogical prompting. That's why it is said that humans will solve problems by recalling the related problems that we have faced in the past. And from there, we derive certain solutions and apply it, right? So this is exactly what DeepMind is trying to tell. So the advantages of these analogical prompting is that it imbues the LLM to self-generate certain examples, eliminating the need for manual labeling of reasoning examples. So it will self-generate these examples from the past experiences so that we don't need to now feed in a different scenario-based examples or logic-based examples to the LLM itself, right? And it removes the overhead from RAG or prompt pipeline approaches by offloading some labeling and creation of few shot training data to LLMs. So we've seen few shot training. Few shot training in the sense we give an example and then we give a prompt saying, just like the below translation, now translate this sentence, right? So we give an example reference and based on that, we ask the LLM to solve a problem for us. This is completely similar to that. So you're trying to remove the overhead from RAG or the prompt pipeline approaches. So usually what is RAG, right? If you have an LLM and you're trying to solve a particular problem, you feed that particular LLM with a lot of textual data, which is related to your client project. Okay. And then it will start taking all those labels and the data that you have given, training data. And based on that training data, it will learn the labels, learn how to label the data. Instead of that now, analogical prompting will allow it to basically, so there is no overhead, there is no too much load on the RAG, reliance on the RAG technique or RAG approach. Rather, you can just, by offloading some labeling and creation of a few short training data to the LLMs, we can solve this problem. Okay. Then what are the challenges which are addressed by this analogical prompting, right? So you can overcome challenges faced by existing chain of thought paradigm, specifically relevant guidance and minimizing the manual labeling. So you don't need to manually label the data. Instead, it is going to do that by itself by the existing chain of thought paradigm. It introduces the concept of automating the generation of relevant exemplars to guide the LLM's reasoning process, right? So instead of introducing, I mean, it allows you to introduce this automating process completely. So relevant examples will be generated on their own and then reasoning process, it's going to take care of the reasoning process. Then you have something called as research question. So basically explores the possibility of achieving best of both worlds by automating the generation of relevant exemplars and addresses the challenges faced by zero shot and few shot chain of thought. So all the challenges that we face in zero shot prompting, few shot prompting, right? Wherein the example is not given properly or the example is not understood properly, all of these challenges are now gone because it will automate the fact that LLM is now capable of generating its own examples. relevant examples and draw inferences from that. Then you have meta ask self consistency. Again, meta prompting. Meta prompting is basically a novel approach focused on improving agent performance through self reflection and instruction amendment. So, allowing you to improve the performance based on reflecting on itself and instruction of the amendment. Key principle here is fundamental principle is to prompt the agent to reflect on its own performance. So it's going to reflect on its own performance, the model itself. And the agent amends its instructions based on the self reflection. So, based on self reflection, it will change its own pathways, its own instructions, how it is working, based on its own self understanding. It's like leaving a child alone to learn by themselves instead of, so if let's say a person is trying to memorize a history textbook, rote learning, right? So, you instead of going and asking him questions and trying to make him remember, he's doing that with himself, right? He's asking himself the questions and doing the rote learning. Simple. Meta prompt creation. So it utilizes an overarching meta prompt that guides the agent's self reflection process. It involves the creation of meta prompt through prompt tuning, a more technical and opaque process. Okay, so opaque process in the sense where we're unable to try exactly understand how it works at the back end. It's more technical and all of that sort. But you're basically overarching a meta prompt in order to speed up this self reflection process. Okay. So that's what this meta prompt creation does. It's going to speed up your self reflection process. Then you also have looping process. The agent follows a looping process starting with no instructions. Okay. Engages in a conversation with the user, receiving requests, instructions, or feedback. So whoever is using this LLM and giving some instructions, receiving the request, right? Probably engaging in conversation then with them is better. Taking a feedback with them is better. At the end of an episode, it generates a self-criticism and new instructions using the meta prompt. Then you have fixed instructions using the meta prompt. This will highlight the fixed instructions submitted to the agent constituting the meta prompt. It emphasizes that between iterations, the agent retains memory only of the modified instructions, continually refining its process. That means whenever it's repeating this process of self reflection, etc., how many ever times in the memory you modify the instructions, change the instructions, it will start giving, refining its own answers also, right? Performance will also same. So if you give a different instruction, if you ask for something else, it will. So, for example, what is data science is one prompt. Asking the same question in different ways, what does a data scientist do? Or what do you mean by data science, right? This could be a completely different question. So, it can improve itself. Then, benefits. It enables dynamic adaptation and improvement in the agent's performance. It offers a unique perspective on enhancing AI capabilities through self critical evaluation. So you will see that there is a unique perspective on enhancing these capabilities of AI based on the fact that self-critical evaluation, right? So you're self-evaluating, self-reflection process, whether answers are correct or not, or to what extent they are correct, okay, where you have gone wrong. This is the self-critical evaluation. Then we have certain applications of meta ask, self-consistency, potential applications in various domains where continuous learning and adaptation is crucial, represents a step forward in developing more autonomous and self aware AI systems. So, self aware AI systems are pretty important for us, and autonomous AI systems are pretty important for us because they, once they are automatically, once their functioning is automated, less and less human intervention is required, and you can get more tasks accomplished in less time. So that's pretty important. And any domain where things are evolving continuously, right, you can use this kind of meta ask self consistency. Then we also have React. Okay. So introducing the React framework. React framework was actually developed by Shunyu Yao and a group of researchers. So he's the main guy, and some other researchers who have worked with him have introduced this prompting technique. React. This framework was introduced in the year 2022, okay, under the publication of Synergizing Reasoning and Acting in Language Models. Synergizing is to combine something, right? So, synergizing this reasoning and acting, these two kind of capabilities in the large language model. He has proposed this idea, React prompting technique idea, in the year 2022, and he has published something like this. Shunyu Yao and his group of researchers, their team. And the core concept is that React combines acting and reasoning in large language models. So, what happens usually a human being, whatever I find reason in, only on that I will react, right? If there is a reason that I pick up a pen, there might be a reason behind it. Without a reason, I'm not doing randomly, right? Actions are not random. Actions are because you have some motive behind it. So that's the kind of capability we are going to give the large language model as well using this React technique, React prompting technique. How does this React function? Okay. React functions using reasoning traces and task specific actions. So, what are these reasoning traces? So, the React will enable the model to induce, track, and update the action plans, including handling exceptions. So, you will be able to track an action plan, bring an action plan into the picture. And once you have planned something, how it's going to go forward, you can track it. You can also update, make any changes to that action plan, including handling exceptions. Handling exceptions in the sense any errors that you face while taking the action, you'll be able to handle those as well. Then you have task specific actions. They allow it allows basically interfacing with external sources such as knowledge bases and environments, correct? Or environments. So you can interface with some external sources or knowledge bases and all that using these React. Then comes interactivity with external tools, how React will enable LLMs to interact with external tools for additional information. And it enhances the model's ability to provide reliable and factual responses. So, whatever is being there, basically something has to, whatever is being fed into the LLM, there has to be some filter, some sort of human evaluator who tries to understand the motivation behind this, right? So this external tools will enhance the LLM model to be able to provide reliable and factual response to LLMs. Then what are the performance and results? So this React will outperform state of the art baselines on language and decision making tasks. That's a huge claim, right? That they're investing so much in React, and the fact that they're believing that React will outperform some other baselines. Performance and results again improves human interpretability and trustworthiness of LLMs. So, because if we are not able to understand what exactly an LLM does, we'll not be able to improve it. Okay, then how do you integrate this React with chain of thought? Best results achieved and combining your React with chain of thought enables the use of both internal knowledge and external knowledge for enhanced reasoning. So you can take care of both external and internal knowledge. And when you combine with React with the chain of thoughts, you'll get the good results. Okay. Now, how does this React exactly work? React will employ a process individual. React employs basically a process involving thought, action, and observation to guide the LLMs. Okay. Illustration of chain of thought prompting method allows these LLMs to adapt plans based on some new information. And example scenario could be elevation range injury, showcasing the thought action observation cycle. Okay. So example scenario is that we're trying to inquire the range, specific range which the company has asked, showcasing these observations of thought of action, chain of thought of action will be considered. Then what are the benefits of this React prompting technique, right? Why should I use this React prompting technique in the first place? So there are a couple of benefits. The first one could be it addresses issues like incorrect facts and compounding errors in LLMs. For example, if I'm asking, what are incorrect facts? So if I say, where is Shah Rukh Khan's house? And ChatGPT starts hallucinating, it gives a desired interest. Maybe it's giving my own address, right? So all of these kind of things are addresses in the LLMs. And then uh, it offers a dynamic and adaptive approach to learning new tasks and decision making, right? Then we also have OPRO, which is optimization prompting technique. So optimization by prompting technique involves a technique developed by Google DeepMind that utilizes large language models to optimize prompts for various tasks. Instead of manually crafting and fine tuning the prompts, it leverages, okay, this YouTube leverage LLM's ability to understand the language and okay, so such that fine tuning. So instead of manually crafting and fine tuning the prompts of Opro leverages the LLM's ability to understand the language in context of iteratively generated new prompts that improve the performance on a specific task. Okay. Now, how does the Opro work? Opro states that through an iterative process, you start with an initial process. So, how do you achieve all of these things, right? So, operates optimizing prompting, optimization prompting technique. First, what we need to do, let's see the step by step process. Okay. So, the first one would be you start with an initial prompt. So, you give any basic prompt outlining the desired task and any relevant example. So, let's say we're giving an example of a data set that we have already worked on. Let's say client data. And while looking at this client data, okay, fine. So we start with an initial prompt. We provide a basic prompt outlining the desired task and any relevant examples. Then we have LLM generating new prompts. Okay. So based on the initial prompt and his understanding of the task, LLM will create new variations. Okay. Evaluating the performance. So each new prompt is evaluated on its performance on the specific task, which is Bollywood, right? So LLM generates the new prompts. Okay. So we are evaluating the performance. Each new prompt is evaluated based on its performance on the specific task, whether it be accuracy, relevance, or creativity. Then we select the best prompts out of all of them. So the best prompts with the highest performance are chosen for the next iteration. Again, we're going to repeat. Whichever models are giving me the best results of the prompts when we are evaluating. Again, we're going to take that and keep repeating the iterative process. Iteration means to repeat something. So we keep repeating that. So repeat the process. The process continues iteratively with the LLM generating new prompts based on the text performance from the previous round. Okay. So this is like a continuous process that keeps going on. This is your optimization prompting. Let's see a couple of benefits of these optimization prompting. So it will allow you to automate prompt optimization. So it basically eliminates the need for manual trial and error, saving time and effort. Instead of doing trial and error prompts, so giving an input, then checking the output, then again giving an input, checking the output. Like this, instead of doing several attempts, you can do it simply using a trial and error method. And since the accuracy is also high, that's what happens, right? So how do you improve the performance? Opera can often achieve better performance than manually crafted prompts. Okay. Handles complex data, complex tasks. Opera can be applied to various tasks, including text generation, translation, and summarization. So text generation, I can say write a poem, write a story, and then give it to me in this way. So you can generate text, or you can translate something, or you can do summarization also. And it will also provide a lot of insights. So insights in the sense it will analyze the generated prompts that you can gain through valuable insights into the task, the how the LLM is working, right? So these are the four benefits of Opera: automating the prompt optimization, improving the performance, handling the complex tasks, and provides the insight. Okay. Then comes, okay, there are some examples of how OPRO is being used, this optimization prompting. The prompt optimization for large language models is nothing but Opera can be used to optimize the prompts for various lengthy model tasks, such as answering the questions, text summarization, creativity, or creative writing, right? Then you also have iterative prompting. Iterative prompting is nothing but refining language models in steps. Iterative prompting is a fascinating technique emerging in the realm of LLM, so it is relatively new. It goes beyond static. It goes beyond the static, pre-designed prompts and embraces a dynamic step-by-step approach to guide the LLMs towards better outputs. Imagine it as a sculpting a masterpiece through the success refinements, whereas prompt towards uh, you know whereas each word prompting iteration adds precision and detail. Here's how iterative prompting works basically. So the first thing in the initial prompt, you can start with a basic but informative prompt outlining the desired task in any relevant context. Okay. Then comes the response of the LLM. So large language model, it has to give a response. So the LLM will generate an output based on the initial input. So analysis and feedback again, you or any other system is basically trying to analyze the LLM's response, identifying the strengths and weaknesses. This could involve assessing accuracy, relevance, creativity, or any of the task specific metric. But okay, then we also have refined prompting. We'll do refined prompting based on the analysis. You refine the initial prompt by adding or removing or modifying instructions information. This might involve providing more specific examples like clarifying instructions, courageous things and all. Next iteration, the refined prompt is fed back to the LLM, the continuing, prompting it to generate a new output. So refined prompt is led back to the LLM, prompting it to generate a new output. Then you have repeat. So the cycle of analysis, which is feedback, right? The circle of analysis, feedback, and refinement. All of these will happen continually, iteratively, again and again and again. Process is being repeated. Iteration means to repeat. Until they achieve the desired outcome, they can keep running the multiple iterations, with each iteration leading to a progressive better response from the LLM. So every time you run the code and every time you run and get an answer, so you can achieve the desired um, outcome or desired label or desired result or target, with each iteration leading to a better response from the previous one, right? That's iterative prompting. So there are certain benefits and examples of this as well. Benefits are high quality outputs. So by providing continuous feedback and guidance, iterative prompting can significantly improve the accuracy and creativity of LLM inputs when compared to the static prompts. Then you can handle complex tasks, you can gain insights, you can have adaptability. Complex tasks in the sense, it will work when you have complex tasks where simple prompts might struggle, such as multi-step reasoning. You can do this, right? Chain of thought, open-ended creative tasks, all of this you can do. Then the iterative process itself reveals that LLM processes the information and generates its responses, offering valuable insights into its internal workings. Then adaptability. Iterative prompting can be tailored to a specific task and domain, allowing for the fine-grained control over the LLM behavior. Then you have a couple of examples here. You can say writing a story. So you can start with a basic plot outline and character description. After each generated chapter, provide feedback on the plot coherence, character development, and prompting, pacing, and the LLM to refine the story in subsequent chapters. So all of this information you have to feed in to do this, to write a story using iterative prompting. Then you can also solve a mathematics problem using this iterative prompting. So you can begin with the problem statement and initial steps. Okay. Analyzes the LLM solution attempt and provides hints or clarification if needed. So through successive iterations, it guides the LLM towards the correct solution, revealing its reasoning process along the way. So this is up till iterative prompting. So today we have seen a few advanced prompting techniques. One of them is analogical prompting, right? Developed by the Google DeepMind. Then you also have MetaAsk, self-consistency. Then again, React. React again, it was introduced by, developed by Shunyu Yao and his group of researchers in 2022. So how to synergize reasoning with action. Then comes optimization prompting technique. In this technique also, we can start off with asking ourselves what is exactly OPRO and how does it work, right? Then we also looked into iterative prompting, how this can be advantageous to us. So this is also one of the methods wherein, you know, the analysis and feedback is being applied. Okay, task specific metric, etc. These kind of things. How does iterative process repeat? And especially what are the basic advantages or benefits of using this iterative prompting over the other techniques? And we've seen a couple of examples, right? How do you solve with a math problem? So begin with the problem statement and you give the initial steps. Analyze the LLM solution attempt and provide hints or clarification of that mathematical equation if needed. And then it will, through successive iterations, it will understand guide, whether we can guide the LLM towards the correct solution, revealing its reasoning process along the way. Okay, so these are the few prompting techniques we have seen today. We'll meet next weekend and continue this. We'll learn step back prompting, input output prompting, chain of thought. A lot of different prompting techniques are there. We'll continue our discussion, right? So, thank you so much for joining in today, guys. Please like, share, and subscribe, and let us know in the comments section below what are the topics you want us to cover, and which are the topics you're excited about. Stay tuned. Thank you. See you again next week.